Up until now, the problem with building applications has been that before you could even start, you had to choose a framework, learn how to deploy that framework onto servers, then manage and maintain those servers over time. Not exactly easy, quick, or efficient. Thankfully now there's Azure Functions, the easy way to build the applications you need using simple serverless functions that scale automatically to meet demand. No worrying about infrastructure or provisioning servers. Whether you're new to development or a seasoned pro, within a few minutes, Azure Functions helps you create applications that accept HTTP requests for a website, processes product orders via queue messages, react to data flowing from devices like an IoT hub, or just run simple scheduled tasks. And since Azure Functions scales automatically, all you need to do is write your function logic. Azure Functions handles the rest. What's more, you only pay for what you use. With Azure Functions, you'll write less code, manage less infrastructure, and have a lot less upfront costs. See for yourself at functions.azure.com and try it, free. You'll see that making applications has never been easier with Azure Functions.
Hey everybody, welcome back. It's me, it's Jay. Welcome back to AzureFunBytes. It's really cool to have you again. Thanks for joining me. And of course, we lined it up. What are we going to talk about today? We are going to talk about Azure Functions. We just got a quick introduction to what it is and what it does. And I've got a guest today to help me out with it. And we'll get to him in just a second. But thanks again for watching. We've got one more to go for the rest of the year. And until then, we're going to keep doing this and enjoying having conversations about working with Azure and the fundamentals that come along with that. So I'm going to bring in my guest. He's been here before, and I'm very, very happy that he's going to join me again. So let's bring him in. It's Dean Bryen. Hey, Dean, how are you today?
Hey, Jay, I'm good, man. How are you?
I'm doing great. I'm really, really glad to have you again. I think it was fun the last time we did this. We focused a little bit more on security, and I think that was really important because security is a huge kind of high-level topic. No matter what portion of the application that you're building, you need to think about security first. And so that's huge. So let's talk a little bit about what we're going to do first. It's really a simple kind of idea of let's take maintaining the server out of the whole idea of working with applications.
Yeah, exactly. Security is one of my biggest passions, right? As everybody probably knows, who knows me, but also another passion of mine is serverless. It's one of these things where, when I first got exposed to serverless, which was back in 2014, it blew my mind. It was like this is awesome, man. I can just create, run code in response to events. Back then, we didn't really have some of the functionality we have now. You couldn't even do, and we'll get into this, but we couldn't even do web APIs or web apps with serverless at the time because it wasn't synchronous. It was just asynchronous tasks that we could do with it, right? So you couldn't have it as a HTTP backend. And it's evolved massively since then, and we'll talk about some of the use cases. Mm-hmm. But yeah, it's the idea of just this is the way I think, Aaron. I know you're the same, Jay, right? We've spent years administering, operating, managing servers and infrastructure. And honestly, if I don't have to do that ever again, I'm in.
Yeah. I really don't want to deal with the idea of the long-term care and feeding of all the components. It seems a little bit more than it's really necessary in our current way of working with applications. We're at a really good place nowadays. We can make decisions that work for us that don't necessarily have to take all of our time. And I think that's a really good way of putting it. We can simplify a lot of these processes by putting them into code rather than servers. And I think that's what it really comes down to.
Do you know what it comes down to really is you can still be super technical and use serverless, right? And there's always going to be some element of ops and stuff involved. Mm-hmm. But the reality is that all that stuff that people are doing, administering servers and stuff like that, it's not it's cool. It's cool tech, right, for us as techies and individuals, but it's not really like, it's undifferentiated heavy lifting, right? It's not going to differentiate your business. It's not going to move your company forward. If you're a startup, right, I'm sure as a startup, you would much rather have engineers pushing features for your, like, doing business logic than running servers, right? So this way enables us to do.
What we're really looking for is people building our applications, as opposed to people, I don't know, trying to maintain a bunch of equipment that doesn't necessarily benefit the entire business, because you may be spending time on hardware upgrades and things like that, but there's no guarantee that, like, long term it's really going to be useful, because maybe, I don't know, maybe it's not in your best interest, I'm not really sure, to spend that much time on architecture and to spend more time on really code.
Yeah, application logic, yeah, business logic, features, right? Shipping features for your apps, right? That's what we want to do, right? And before, like, of course, it serves a purpose, right? Servers are an enabler for that, right? Building these platforms, right? But if we can have them same platforms and the same functionality with less management overhead, I'm in. I'm sold.
Absolutely. So let's start looking into it. So I know kind of what this is. I understand, like, the basics of what we're talking about. We're talking about serverless, but I'd love to hear a little bit more about just, like, what it kind of looks like as far as Azure and the big differences between, like, functions and general serverless. So I think I have a doc here that I'm going to bring up, and maybe you can help me through it a little bit. What do you think?
Yeah, let's do it.
Okay, let me see where it is. The serverless documentation. Is it hosting? Let me bring up the screen here. Chrome tab, Azure Functions documentation. So let's kind of get started with this. Like, I believe that there's a portion about, in the overview, of the different types of functions and what they are and the different use cases. And so these scenarios seem to be like the real world use cases that make a ton of sense. Yeah,
exactly right. So I think it's probably worth, like, just taking a step back and differentiating what serverless is and what functions are, right? I think sometimes these terms are used interchangeably by people, and they say, oh yeah, like, I'll often all the time hear people say, like, Microsoft's serverless offering is functions, right? And that's not true, right? Functions are a service which is serverless, but they're not. That's not all. Serverless isn't just functions; it's beyond that. So, like, the easiest way that I can probably define it, and hit us up in the chat if this makes absolutely no sense or it does make sense. Or if you've got a better way of describing it and you're familiar with it, is that a service needs to meet 3 criteria to be truly serverless. It needs to have complete abstraction of servers. You literally don't care what the underlying servers are when you're using it. It needs to scale automatically without any user input, right? You don't even have to configure auto scaling, right? It just works, right? It just scales based on demand. And it should be pay as you go, right? You should never pay for idle, right? So it should always scale to 0, never pay for idle, right? So if you don't get any requests, you're never paying, right? You only pay per request. Now, if a service meets those 3 criteria, then it's truly serverless. And some of this is my opinion, but here
it is, the serverless comparisons. At least here, I think this is really
useful. Right. So here you go. So if you scroll up slightly, oh no, you got it there, right? Yeah. So yeah, this list here, right? So you have Microsoft Power Automate, which is more of a kind of business app type product for less technical people, but sure, like, it's completely serverless.
One of those, like, citizen coders kind of situations where people can use, like, graphical based methods to build underlying code.
Yeah, exactly. So Power Automate is like flow, so it's like asynchronous, like graphical based, like, flow diagrams that you're integrating with a bunch of services. It's very similar to Azure Logic Apps, actually, another service which enables us to do integration, basically. Their integration service
are amazing, and I got to do a show on Logic Apps one of these days, because their use cases. I know. I think we talked about this a little bit when we discussed, like, security stuff,
like automated response and stuff.
Yes, automating responses and using triggers to be able to let you know when things happen, sending emails, sending SMS messages, also using maybe native tools that you have. Maybe you've got an old Nagio system that you want to actually feed stuff from and to. I mean, these are all possible because in the end it's just APIs, and that's what I think I'm trying to get to here with using these like Azure Functions. In the end, it's just really leveraging APIs to do what it is you want to do without having to have everything else underneath to support you. You don't need to worry about those things.
Yeah, like that's the idea, really. That's basically what it's all about. And Logic Apps is like, you should 100% do a show on Logic Apps. I'm a huge fan of the service. The other service there that we have is Azure Functions, which we're going to talk about today, and that's I guess it could be referred to as event-driven code, right? It's running our own custom code in response to an event happening, right? And that event could be an item being added into storage. It could be an update in a database. It could be a web API call. We heard a few of these examples, something being added to a queue, right? We heard these examples in the intro video that was right off the bat.
So I think this is a great kind of piece from the documentation right here. I just want to be able to share with everybody. Like this actual view of the different function capabilities and trigger events, I think is a really useful kind of piece of documentation for all this. So I'm going to put that here in the chat actually, so you can look at this docs. I think it's really useful for you. But these trigger events, let's just talk about those for a second, because I think that's really the power of using functions or serverless in general. Is that a thing happens because of a trigger in general. And that trigger could be time and date. That trigger, obviously, we could just talk about time. Something in a storage blob, when I guess a new file enters, it can have a trigger that says it's time to do this to the file. And let's think about that. I want to give you a really easy way of thinking about that, Dean. Maybe we're dumping lots of raw video into a storage blob because we work for an organization that gets raw video from live shoots, different places. And then you, as the video producer, your job is to go ahead and upload that video to the storage blob, and through some sort of function or sort of a method, and then all of a sudden the function will see that in the storage blob and say, it's time to do something with this new file. And so these are the kind of triggers I love. So you want to tell me a little bit about the service bus one?
Yeah, very similar thing, right? This is queues and topics, right? Items being added into a queue. Azure Functions will constantly be polling that queue to find out like when new items are added to the queue. So like
standard messaging queuing. So like old RabbitMQ and stuff like that.
Yeah, exactly. So service bus queues is an alternative tool to something like RabbitMQ. I mean, anyone who's watching this who's built any kind of systems or worked for any company that's like has probably seen some form of queuing somewhere. Serverless is a great way to consume them queues, right? And actually, it's queues is a really nice way to actually. It's worth mentioning that point. I think that queuing is a really nice way to dip your toe into functions and serverless. Sometimes it doesn't make sense to replace your entire app with serverless, right? I think people sometimes see this and they go, yeah, that's really cool, but we're so far away from doing that as our company. But just think, like, have you got like an asynchronous task that you've broken out into a queue? Have you got an asynchronous task that happens and you haven't broken it out into a queue yet? Like from an architecture perspective, that's always like a great scalability thing that you can do by like decoupling your services via queues. But if you've got like a bunch of workers that consume a queue, like that's a great use case to start off and dip your toe in the water with serverless and start consuming the data from that queue. And just, whatever the logic is, right? That could be transcoding images, videos, like you mentioned just there, like any asynchronous task that you want to do.
Or some sort of data ingestion either because let's think about it from this standpoint. Maybe you're not dumping a binary file. Maybe you're dumping unstructured data. And that actually gives me a great kind of transition to our next one, which is Azure Cosmos Db. So let's say somewhere along your application process, you need to dump something in a database along the way, customer data, any of that kind of data that you would have along the way, maybe logging information that you're currently storing in a database. So what I think is really great here is when a new type of piece of data gets stored in the database, Azure Functions can also monitor it, because if you look at some of the things in, say, MongoDB, there's change streams that will actually have an update. The change stream can send an information to the function, and then the function can actually do what it wants with the data. So maybe it sends a notification to someone that says a new sale happened, and this is the data that, and maybe it goes over to the portion of the team that does the fulfillment. These are like the awesome things where you don't have to actually go and install Windows, install Linux, configure a container.
Yeah, like, we could have done this before, right? Like we could have done this all before, but we can just do it now without having to worry about how we do that. We just worry about the logic, right? What are we actually going to do with it, right? Cosmos DB one is awesome, right? Event updates in a database. Like I've seen people use that a lot for like enrichment of data. Like something gets added into a database, get the data, query some other APIs to enrich that data. Maybe you're getting user information on an internal app, for example, and then you take that user ID, you head over to the Microsoft Graph API, you get their manager's name, what team they're in. Maybe you update the status, whether they're online or off, whatever it is, right? There's a whole bunch of things there. I want to talk about HTTP as well, actually. I think,
I'd love you to. So that's another great one. The HTTP. So webhooks are like an old kind of way of triggering like remote APIs or whatever, remote applications. People have been using webhooks forever. But the fact that like you can still integrate these things, because a lot of developers, they just know how to use them.
Yeah, and Logic App supports webhooks as well, actually. To trigger them, which is a good point. Like HTTP is great because what this enables us to do is it enables us to, like, ignoring kind of webhooks, but like just pure HTTP, it enables us to build web applications and backend web APIs, mobile backends, using serverless, right? And actually, if you think of all these use cases here, right, most of them are asynchronous, right? Let me know something's added, go do something. Let me know, add an item to the queue, go do something asynchronously. But HTTP becomes, we can do more synchronous tasks, right? Like request response type stuff that we expect in a web world. We can build web APIs and stuff like that. There's a whole bunch of possibilities. And I think like that's a natural use case that sometimes people think of because they see a lot of content around this, like HTTP based functions and building serverless APIs. And don't get me wrong, like it's a great use case for it. But I do encourage people to look at some of the other more integration type use cases that we spoke about already. Like timers, man. Like timers. Like that sounds boring as hell, but like that's like the death of cron.
If you need something to happen every single day at a certain time, it makes sense. Maybe timers are a really useful portion of what you're doing. I look at it like this, and this is my kind of feeling about functions, and we can kind of finish up with Event Grid and then maybe kind of get into something. But I love the idea of functions killing the cron job box. You know what I mean? For a lot of us who've worked in systems administration and operations, or DevOps, whatever it is you want to call it, a lot of us have had to deal with the cron box. The one machine that's somewhere on your network that its only real use is to make sure that things happen every single time. But let's talk about that. Like, there's no reliability because if the server goes down, it's not going to happen. If your monitoring isn't great, you're not going to know. And then here was the big thing that I used to get hung up on all the time, and it really stunk. Like, the cron would happen, and the emails that would send me to say the cron happened would get filtered. And because there were like, root system emails, and then I had to like go and configure the MTA, and I would spend all this time just making sure that like every day, like a directory got emptied. And so I think about that now, and like, let's do things like event-driven, time-driven, whatever it is, even if it means going on your Windows machine and doing some sort of event-driven task that hits an API that does a thing across your application. I don't know what it is, But the fact is, let's use these. And so let's talk about one more thing. Can you tell me a little bit about the event grid trigger?
Yeah, event grid isn't just it's a trigger, right? But it's also like another one of our serverless offerings, right? Event grid gives us a kind of it's a router. It's an event router, right? It's like a pub. It has people that publish to the event to the grid and subscribers to the grid, right? And we can send events in and have them pushed out to consumers of those topics, right? And those topics are functions, right? Like the consumers can be a bunch of stuff, but one of those consumers of an event grid can be functions. And it's super powerful for people that are chucking a ton of events. Really, really nice.
Well, one of the things I want to really do next, and you and I have talked about this before, is you've got some really great content that you worked with in the past that can help people get a bigger view into actually what makes up a function. Like before we actually like pull in and start creating or working with one or going through the code, you've got a really interesting deck that just has a couple slides that I think that will help kind of get us through the next portion of our conversation. Sound good?
Yeah, exactly. Yeah. So let me try and just do that.
While he's doing that, everyone remember, please let everybody know we're on also LearnTV. So if you go to aka.ms /LearnTV, I'll put it in the chat. You'll be able to watch this here, also on LearnTV. It's a great spot where there's a lot of other shows. So when you finish up with us, you can watch another one of the really interesting and informative kind of programs that we try to do here every week. It gives you lots of different topics. So keep your eye on LearnTV and watch FunBytes on it. So,
right. So I think I'm sharing my screen, but
there you go.
All right. Once I play this presentation, I can't see anything. So, like, tell me.
All right.
All right. So
I can see you, and you're beautiful, man. You can go ahead and just talk, and I'm gonna actually go full screen with your slides, and you can just let me know when you're done.
Sweet. Yeah. So, so I've got some content I did here around like serverless security. This was around serverless security, but before we got into the security aspect, we had to cover what serverless was, right? So very quickly, it's really worth kind of going through this and talking about what serverless is and what Azure Serverless is, and particularly what functions is, right? So I love this graph from Tal Melamed, he was a founder of a serverless security company, and it just shows you the kind of evolution of compute that we have and the options that we have. So with serverless, it shows here that the stuff in gray is what the cloud provider looks after for you. Mm-hmm. So the point here is that in serverless, we only really care about a couple of things, right? So we care about our code and our configuration, right? So we need to configure these serverless things, right? We need to configure our functions, we need to configure our function apps, our storage accounts, our Cosmos DB databases, our queues and event grids and whatnot. But we just really care about configuring those and our code, right? Our logic. Mm-hmm. And I mentioned earlier those three key components of functions, right? The three things like the scale to zero, pay by use, and complete abstraction of servers. Mm-hmm. And in my opinion, these are the three services we have in Azure that really nail that. But of course, you can't just build a whole entire serverless application with just a function or just a logic app often. You need to supplement it with other services like databases or storage, and you need to secure it and do some analytics and all that lovely stuff as well. And then, of course, you then need to be able to develop on it, right? So you need like DevOps, you need like local dev, monitoring, debugging, IDEs, like all that stuff.
So this is where like using VS Code, using GitHub Actions, being able to integrate also like Code Live, using what is that name again? The new VS Code Code Share.
Live Share or Code Spaces.
Code Spaces, that's what it is. Yeah. Monitoring also.
Yeah, exactly, right? Like these things are still important, right, in a serverless world, right? How we actually develop and deploy these services. So that's kind of like a whirlwind tour of what we have in Azure from a serverless perspective, and how like what's truly serverless, what's supplementary and really helps build entire serverless apps or architectures, and then some of the dev stuff. I want to focus really on functions because this is what this FunBytes episode is about, right? Mm-hmm. So Azure Functions is basically a service that enables us to respond to events, as we saw those triggers there, right? And run some code in response to those events. But let's dive a little bit deeper into what that actually means. So in Azure, and some people here will be familiar with this, and I'm sure you've covered this before, but everything in Microsoft Azure resides in a resource group.
Yep.
So
those are like, I like to call them like egg cartons. You put something in the egg carton, you take something out of the egg carton, you move it into another egg carton, and when you're done with the egg carton, you can throw the whole damn thing out.
Yeah, do you know what? Resource groups is a feature. It's like one of my favorite features of Azure, right? Because especially in what we do, right? We build a lot of demos and stuff like that. I can just build, throw stuff up, and like just delete the entire resource group and tear the whole thing down, right? But also from a permissions perspective, it's just a lot. It's a logical container of our resources, right?
Absolutely.
So what we have in Azure, and if people have done serverless in other cloud providers, there might be they might be familiar with a different way of doing this, right? Other cloud providers, some of them have the ability, like you just have a function and you hit that function and it runs and it's kind of independent as a function. The way that Azure is built is slightly different, right? And I don't want to say that one is the right way and one is the wrong way. And you know what it's like, Jay, right? I guess the way it is, right? If you and I were both tasked with going to build a serverless platform, we'd probably come up with a slightly different end product, right? And that's kind of what's happened.
Absolutely.
So there's pros and cons to each. But in Azure, we have this concept of a function app. And a function app is actually what runs in Azure. That's like our hosting environment, basically. That's the server or the servers that our code is actually going to run on, that's abstracted from us, right? That sits in Azure. And then on top of that, we have functions, but we can have multiple functions per function app. So this could be a little bit, but this example here, right? Function A here is a HTTP trigger and receives GET requests, and function B is another function that takes GET and POST requests. These are both functions, but they both sit on the same function.
Sure.
Now,
and so the GET is kind of just doing get the information, just you're not doing anything else. You're just bringing it and ingesting. And then the function B, I just want to make sure everybody's clear. You're ingesting and then you're also giving back in that post.
So so exactly. So the reason I say this is that these are design decisions that people make when they're building, specifically talking about APIs on serverless here. If anyone's built APIs, right, we have the typical Crud actions, right? Create, read, update, delete, right? They're the operations we like basic what we would perform on an endpoint, right? So you could have one function to do create, one function to do read, one to do update, and one to do delete. So you'd have 4 functions in your function app there, right? One doing each of those things, right? Another thing you could do is you could have 4 different function apps, each with one function in, one doing create, one doing read, one doing update, one doing delete. You could have 4 functions in the same function app doing that, right? So my point here is that people design this differently, right? And that's based on personal requirements. And there's some benefits to this and there's some cons to this, right? So one thing that functions have, and it's worth calling out now, is they have what are called cold starts, right? And cold starts mean that the function isn't warm yet, right? Because it's an underlying server that's sitting idle for however long, right? Until somebody hits it, all right? And it takes a little while to warm up and get the runtime available. A couple of seconds, sometimes less than a second, hopefully, to warm up and receive that first request. Now, for web-based APIs, that's important, right? You care about that because you don't want it to take a second to warm up your API. For asynchronous processing like transcoding or whatever, like you don't really care if it takes an extra second to trigger that job often. So one of the pros to doing the function app model is that you can have like your get, post, delete, update all on the same function app, and then say that your get request gets loads and loads of requests. It's always, your function app's always warm, right? And then when your delete request gets a request, it will also be warm, right? Because it's on the same function app. So that's got like a nice benefit to this. The downside to that is that from a security perspective, like that function app is your boundary, right? That's your kind of security boundary. So function A can always access the code of function B, right? So from a security perspective, you just need to be a bit wary that you shouldn't have like the finance department having a function on the same function app as like your web facing like custom,
Sure.
right?
Because if there's also a mistake in maybe a database connection, or you make, you know what I mean? There's also a little bit, something to prod that goes to one to another. You know what I mean? Like there's always
Yeah,
a certain level, like a line of demarcation that you should also set between different application functions and what type of data that they're going to access. Just makes sense to me.
yeah, and don't forget that like we don't pay for idle, right? So this costs us nothing if we have multiple of them. So there's no real reason to do that anyway. The other thing that's worth noting in that from a security perspective is that like the function app shares an identity. So if function A needs access to database Y and function B needs access to database Z, then both of them will be able to access both databases. So you need to make a decision around whether that's a sensible decision to make or not, right?
Gotcha. So why don't we go into the portal for a second? Do you have more in here?
No. So do you know what? Like from here, I was going to look at the programming model, but I think the best way to understand the programming model is to go and build a function and
Sure.
see exactly how it works. Yeah.
So the first thing I'm going to do is I'm going to just show everybody how we get started actually building a function at the least, just the hosting level, and then I'll let you step me through the rest. So I'll let you tell me what code, runtime, and all that stuff that we're going to work with. Does that sound cool, Dean?
Let's do it.
All right. So to actually get started in the portal, you can always just go look up function app. That's what I did. And then I did what we always do, like Dean just said, we're using a resource group. It's our carton of eggs. Let's start putting some eggs in it. And so I'm just giving my function app a name. It's going to be HTTPS. My mic is not loud enough. Hey, sorry, Odin. Let me make it a little louder. I apologize. How do I sound, Dean?
That's a little louder.
All right, cool. Hey, sorry about that. I got it. Good, thank you. That's why it's good to have viewers, so you can always tell when you're not. I appreciate that. I thought I projected, and I didn't want to go too.
Oh, somebody said a little bit more. A little bit more.
All right.
Yeah, ramp the gain up.
There we go. Here we go. Test. 1, 2. There we go. When we do it live. And let me bring the mic a little closer to my face. How we doing? Better yet?
Plug in the subwoofer.
I'll put in the real big bass. Okay, cool. So let's keep going through. So what runtime do you want to use?
Let's use Node.js. So that's the point, right? That's probably worth mentioning, right? We support a number of languages, right? .NET, Node, Python, Java, PowerShell. You can do custom handlers now as well, which is pretty cool. We definitely won't be going. That's not fun. That's not a fundamentals topic, but you can actually bring like custom handlers. Some people have done some stuff with other languages like Golang and others. Personally, like I'm most comfortable with Node and Python, so we'll go with Node.
Okay, and so we're gonna go with code over a Docker container, and I'm guessing a Docker container underneath gives you a full container that can run everything. If you need some sort of like subsystem or something, I don't know. Can you give me?
Yeah, so it's funny, right? So there's always this argument, right, of that this war, right? There's some funny videos that have been done. Like there's like a serverless versus containers rap battle somewhere on YouTube, which is actually quite funny. And it's actually the same guy, Forrest Brazil. He's like him rap battling himself. And it's funny because like for me, it's never really been like, I don't think it's serverless versus containers. I think it's more serverless versus maybe Kubernetes or like an orchestration engine for containers, right?
Sure.
A container is often like just your deployment artifact, right? So when we just use code, what we're going to do is we're going to write code, we're going to zip it up, and we're going to deploy it as zip, right? When we use a container, we have our code embedded in a container. Gives you a little bit more flexibility with the packages you want to install and stuff like that. So it is an option, but code is the most straightforward. Code's what we're going to do. Be wary of containers. Like it's a great use case, but then as soon as you've got a container, right, you've got to scan your containers, update your dependencies, and all that kind of stuff, right?
We got a question here, Dean, from Odin Hassan, or Hassan, please excuse me. Diff runtime language can affect the warm up and execution time, right? So if you're using, say, like Python as opposed to like PowerShell core or Java, is there a different? Like I would imagine Java may have a different warm-up kind of runtime, just because how I've worked with JVMs before. But you can correct me. Like, is there any difference in?
Yeah, so there probably is a difference between the runtimes. I'm not entirely sure what it is, but yeah, potentially, like, every language is unique, right, in certain ways. Some of those languages are compiled languages, some of those aren't, right? They're interpreted. There's yeah, it will differ. I'm not sure if we've documented, but I know that there's been community members that have tested this kind of stuff and blogged about their experience with the performance across runtimes. There's a great blog actually called, I think it's called Azure in the Trenches, and they've done some good content on that. So if anyone wants to Google that, you'll probably find some good content around cold starts and runtimes.
So we're just going to go with Ubuntu LTS, but we have the option for a couple different versions. And I would just imagine that's more about the
This is our Node version, by the way, not our Ubuntu version, yeah.
Yeah, oh, excuse me, Node. So this is all about like your version of I think, yeah, now I got, sorry.
You got Linux on the brain.
Yeah. So now we have the option of using our storage account. I've already got one right here, but I can create another one for where our actual function is going to be stored, the code, everything that makes up. And then we can pick whether we want the runtime to be on Linux or Windows. It's Node.js. We could just use Linux.
Yeah, and I mean, to be honest, like, this is something that's funny to me. People go, like, it's really cool on Azure. Like, you can have Windows or Linux, like, underneath. And I'm like, it's serverless, people. Like, we shouldn't care. Like, we really shouldn't care. Like, if it supports Node, then, like, for a lot, like, there are obviously use cases where you need to interact with the underlying operating system, and there's different packages and dependencies that will matter. But for the majority of simple serverless, like, use cases, for a lot of, like, the automation stuff we've been speaking about and simple web APIs, do you really care? Like, it supports Node, right? Pick one.
So we're going to get to that question in just a second, TRP. But let me just go over these different kind of plan types for the different consumption models. So we can do consumption for dynamic scaling, for on-demand, and premium for advanced features and better control over that dynamic scaling, or an app service plan for on-demand execution. So essentially leveraging app service probably to allow you to auto scale quicker because you have kind of capacity that comes along with that plan.
So if you drop the drop down there, you'll see different types, I think, of options for us. So you've got consumption, and then is there a bottom one that's called environment? Is there 3 there or just 2?
It's just oh, there it is. App service plan. I'm sorry. So that's to run it off, leverage an app service plan.
So the way this works is that the consumption version is serverless as I described it, right? It's completely pay as you go. The premium plan gives us the ability to, inside that function app, have some dedicated machines. And this is for people that know they need that guaranteed level of performance. They don't want cold starts, right? They want that machine to always be warm. There's companies out there that are using this at scale where they're willing to pay a premium just to have that kind of ready for them, but then still use the benefits of serverless on top. And what the app service plan does, it enables us to run it in an app service plan, and we can use app service environments, which is like a really isolated instance of app service for them. It's no public endpoint, only accessible from a VNet and all that kind of stuff.
So it's the power of like the serverless with the strength of using the app service plan to give you all the resources that you want that are pre-provisioned or part of your plan. Especially, like I said, auto scaling. So let's go next here. We've got monitoring. We're going to be able to take application insights, which is going to give us performance information on our different portions of our application that we're going to use for this function. We can just store it in this application insights. I guess it's like a workbench that you could eventually work with the data.
I mean, it will create a workspace for us,
And then we can add metadata tags if we want to. We can call this a prod, whatever we want, and then review and create. And so now this is going to set up the ARM template that we can eventually download and reuse if we want, or we could just click create and it'll start initializing the deployment. So that's just how to create the infrastructure, if you will. Dean, you want to take me on the next steps of how?
So you're right. All you have right now is a function app. You don't have any functions, all right? And it's an interesting thing, right? So this is where it differs to other cloud providers if people have used them as well, right? The function app and the configuration for the function app is kind of done in Azure, right? In the portal, right? But the functions themselves, it's actually quite a cool concept. The configuration for a specific function is just a directory in your repository. Right, and you deploy that repository to your function app, and it says, there's 4 directories. That means there's 4 functions. What's this function called? Oh, what's the name of the directory? And this will make much more sense when I show you, right? So I'm here in, you can see my screen here, and I'm in VS Code. Sorry, let me
Can you just up it a little bit larger, just for the sake of everybody? And
I got you. I'm trying to do that.
My old
I'm making you bigger over here rather than the other screen. Hold on.
Hey,
nice and big. There you go. So
I added 2FA my GitHub for a sec so I can follow along. Like, let's. Actually, you know what? We forgot a question, and before we dive in, let's, because it's one that I think is right up your alley. Real quick, security settings. When we did that configuration, was there anything, or is the security mostly in the code you write?
A lot of it's in the code, right? There is some in the functions specifically, and our triggers. We should turn off HTTP. Annoyingly, that's turned on by default. There's actually an Azure policy that you can configure to stop. It would have blocked your deployment unless you had turned off HTTP. A lot of it is in the code, like a lot of it is AppSec and traditional stuff that we would do.
Let me just bring this up really quick, and then we'll get back to you. But
is this the docs, right?
Oh no, this is actually from the function we just created. So let me just scroll through it. You can just show there's bindings, the ability to actually have specific networking configurations that are associated with it. So just simple security.
Yeah. So
before you get into the complicated stuff.
This bit here at the top, right? You can just click there, and it will go. It will go and create you a. It's actually quite cool integration. You click configure front door with WAF, and it will go and create an Azure front door, which is an Edge web internet-based load balancer, application load balancer, with a web application firewall deployed for you, pointing at this app. But yeah, you should turn, like if you go out to the TLS settings up there, people would have seen, the eagle-eyed would have seen, it says HTTPS only. Right there it is. And you've got it off, right? So you should turn that on, right? That's a simple one to fix.
Yep. And then you can pick your TLS version. You can actually add specific bindings with your own certificate if you have it. But anyway, we got 20 minutes, and I want to make sure that you get an opportunity to kind of show everything, and then we got another question for you. So why don't you show us how this gets started?
By the way, just a point actually to TRP. I will dig out the link, but I've done a bunch of shows and talks on specifically on serverless security, and I go through how I break in and hack into a vulnerable serverless app. It's fun, right? And we can probably find a link. It's definitely on YouTube. Yeah, there's a bunch of stuff there. Right. So so I'm actually using Visual Studio Code, right? Because as developers, right, we're generally not clicking around in the portal, and I think the Azure extension that we have here for functions is pretty powerful. So basically, what Jay just did there, right? I'm going to create a new directory here, and I'm going to call it. Oh, not in that one. We should come out here. We'll just move it in a minute, right? Yeah, so so I just created a new directory here called Project 2 in my VS Code. I'm using Visual Studio Code Spaces here, which is completely in a browser. It's pretty cool. I can just use Visual Studio Code in the browser, and this is running in Azure. This is a container here running in.
I love it. I love these integrations. The VS Code and Azure integrations are just so useful for people.
Yeah, exactly. I can just do I've just used a starter here for Node. I created this directory here, and then I have an extension installed in VS Code. If you go to Azure, I actually have the Azure Functions extension installed here. And if I go and sign into my account here, it will bring me over to here, which I'll move off screen a sec. I'll sign into my account, and then it will automatically sync this to my Azure account. So you can see that I've got a bunch of subscriptions that I have access to. Let's pick one here. You can actually filter this out. And you can see a bunch of function apps that I've already got, right? How's my talk? Some serverless security demo. Who was asking about serverless security? This one stopped because it's purposely vulnerable. I'm not going to be leaving that one running. We start that up for the demo. But you can see you can view all of your function apps and all of the functions and stuff that are inside that function app, right here in Visual Studio Code. It's pretty cool. So I have created a new directory called Project 2. If I go Command-Shift-P, which is, I'm on a Mac, which is or Control-Shift-P in Windows. We can just go like Azure Functions, create new project. And it will take me through this little wizard here to create a project. There we go. So it says, like, where do you want your project to be stored? So I'll browse, and then I'm going to pick project 2. Okay. Gives me an option of languages. I'm going to pick JavaScript. And then I can use some templates. I can skip this and just have blank code, but I'm going to pick the HTTP trigger here, which is going to enable us to, our function is going to be triggered by HTTP. I'm going to call this, like, I don't know, get cars, right? Say we have a website that sells an API for car information or something, right? Another security feature here, which at the function level, now function app level is when people access our function, can they do that anonymously? Do they need to provide a key, right? We have an option of a function key and an admin key. This is really good for things like if we had that front door accessing our app, we could choose function here, and then the only thing that would have our function key would be our front door. So if someone tried to bypass our WAF and come into our function, they wouldn't have the key, so they wouldn't be able to. But our WAF would be configured with the key, and you just append that as a query parameter on the URL. Like it's like # key equals like whatever. But we can just
as much protection that you can have as possible.
Exactly,
you know what
right?
I mean?
So
so now you're building you were building out your function from existing code, correct?
So this is just a sample code that comes with as part of the Azure Functions extension, right? So this is like a sample one, but let's have a look at what we've got, right? So all that's done in this project 2 directory that I created, right? It's given us a bunch of files, right? So like this is where we talk about the program model and how you actually use functions. What we care about here is mainly this host.json file. And this is telling us like our Azure Functions version, is application insights enabled. And these are the settings to like for our function app, right? You know what you just created in the portal? Like this is where we can, and you can add, there's more parameters here in the docs.
And if I'm right, we can eventually, in like live VS Code in here, we can use the extensions that are in here to actually publish to the function that we have in the portal, correct?
Yeah, like if I was connected to your Azure account or an existing one that I had, I could just go and deploy to that function app. Yeah, right. Like 100%.
Gotcha.
And I've just created a new one, right? So all we really care about is host.json. We can configure locally and run our functions locally. And this is a really cool benefit to Azure, actually, that I really like. We can use a command line tool called func, which I won't show you we'll show you in a moment when we run it. But in fact, let's just do it. I can do like func host start. And that will, oh, I need to CD into that.
CLI, still going to CLI. Got to be in the right spot.
Exactly. So that's actually like running the Azure Functions runtime inside this Docker container in Visual Studio Code, which is super cool because like the one cool thing is that the Azure Functions runtime is built on .NET Core. It's completely open source. So the runtime that's running here on my machine is the exact same runtime that's running in Azure when I'm running my functions. So it's really great for testing and running stuff locally. So I can run
the same idea with containers. Whatever you're running locally, you should be able to run anywhere in the cloud, anywhere in the world.
Exactly, yeah. And I mean, we can do debugging here and all sorts. And then we've got, so it tells you here, like we've now got this function called get cars. So you see that in here we have this directory called get cars. And if I want to create a new function, I literally just create a new directory with a different name, and I put 2 files in it. I put a function.json file in it and an index.js file in it. Right, that's all you need. And then as soon as I publish this function app, it will pick it up in Azure and go, there's 2 functions in there now. Right?
And I'm guessing that the function is telling exactly where the code is, how to execute it, the trigger and information, and then index.js is the actual code you're executing. Am I getting this right?
You're spot on, man. So in here, you passed the test. So in here, you can see for this particular function, we have what we call them bindings, and we have this is a cool point actually, and we don't have time to go into. We have input and output bindings. Now this is super cool, right? So imagine you've got an input binding of a queue, and your function is being triggered by a queue. But then once you've done something, you want to update it to Cosmos DB or a database. You can have an output binding for Cosmos DB, and then in your code, you don't need to create a connection to Cosmos or anything like that. You just reference that binding, and you write to that binding, and then it just writes to Cosmos for you, and you don't really care about it. This means you can then have exactly the same application code for your test, your dev, your prod, but just change your function.json file with the binding information, right? It really makes, and the other really cool thing, completely swap out your database, right? Move from Cosmos to something else, right? You just have to update the binding, you have to update your code, right? Which is pretty.
Just go in, new connection string. Maybe you want to move to SQL as opposed to, or maybe just want to use one of the different APIs within Cosmos, whatever it is.
Exactly, right? So let's have a look at exactly what this is, right? So these bindings, you can see this parameter called direction, right? Direction in means it's an input binding. Direction out means it's an output binding, right? This is obvious. So you can see that we have the auth level, which I already spoke about, the type of trigger. So we have HTTP, we have options for queue and stuff like that. The direction is in, and we've given this binding a name of rec, right? Request here, right? We have this array of methods. So we support get, post. We can delete that. If I can get my keyboard to work and save the file, and then we'll only support get requests, right?
Gotcha.
And then we have an
that makes it just a read only to everybody knows. That makes it just able to read. It's not going to actually write anything.
Yeah, we only support the get API method for that endpoint. And somebody put in the chat earlier, API management for the win. Yes, you should put API management in front of this, but that's a topic for another day. And then our output binding is like response, right? It just says HTTP out response, right? So when our function is triggered by this thing, we're going to run some code, and then when it's finished, this is what we're going to reply to. We're going to send the response back on HTTP. Now remember these names, right? Rec and res. Right? All we do in our index.js here, we pass in two parameters here, right? The context object, which provides us a load of context about the event that's calling us, and then you can see here we've got rec, right? And we can put res in here as well, right? But actually, we actually don't need rec here, but basically we're passing the context and then we're passing in that variable, right? That binding called rec. And then our code's straightforward, right? We're defining a constant called name, which equals rec, right? The requests that come in, dot query parameter within that request, right? And a name. Or it's given a JSON body and it's got the body and it includes the body and the name parameter within the body, right? And then it's just going to respond the message saying, hello, name. This has been triggered, right? Super straightforward function.
Sure. And then 200 just...
Yeah, exactly. And then at the end, we just respond. We say context.res. So remember, it was called, the response one was called res. So we're calling the context object and then the response output, and we're going to send back response, right? We can actually test this out, right? We can just go to this. I can follow this URL, which is localhost. So we're just running locally on the environment at the moment. This is a really cool feature of Codespaces, right? Remember I said this was all running in the cloud? Yeah. But I can then go to it on my machine as localhost, and it does port forward in for me, which is pretty nice. So I can access stuff that's running as localhost on a container in Azure directly from here. Right?
Oh, and there's your code, there's your trigger. Make it just a little bigger for everybody. There you go. So everybody can see. Yeah. Now that's exactly, and now you can actually go into code, publish it directly if you wanted to a function, or you could go into the portal, create your function. You can use all these different types of languages. You can create a function with Python. You can create a function using the APIs that Azure has by pointing to where these docs are. That's the great thing, is
literally, man, like
limitless, my man, limitless.
We could talk for hours like about this, like, but this is like where you just get started, right? And as you say, like I can go to I can run Command Shift P again and type Azure Functions.
Functions. Oh, there you go. Create new project.
Yeah, like deploy to function.
There you go. Deploy to a function. Wow.
So I can literally just go like that. I can select my subscription that I want. So if I had your subscription here, I could deploy this code to your function app that you just created. And I can select the function app that's already in Azure, or I can go and say, right, create a new one. This is brand new, right? It's project 2.
This is the same, and just so everybody knows, this is the same ARM process that we went through in the portal. You're just filling out that information, and rather than Azure taking and creating that ARM template for you, what's happening right now is Dean's actually creating an ARM template in the background through Visual Studio Code or this Codespaces version. That ARM template eventually through code gets sent to Azure and says, I need this. And then throughout that process, after it creates the resource, VS Code says, after you created this, deploy the code that I have here to that. That's the process. And that's why this is such a powerful platform, because you don't necessarily need to do much other than sometimes, and I know Damien doesn't like to hear this, but you can right click to publish. And that's for something like this, it's pretty cool for a beginner. Once you get into more like complicated deployments, it becomes the thing where maybe you need to integrate DevOps processes, where you have a whole CI/CD process into how the code is created, it's tested, it's eventually brought to the API, and then deployed. And so I think like...
And you can see all that stuff here, right, that you did in the portal, right? It's there, right, in the output. We see we've created the resource group, we've created the storage account, we're now creating the application insights, right? Now it's creating the function app. And you'll see in a moment, we'll leave this running in the background while you wrap up, Jay, but you'll see in a minute that it's going to then deploy, as you said, to that function app, right?
Yeah, absolutely. And so we got a few minutes left. Not many, but we got a few minutes and we got a few questions. And so I think what we can do is just kind of, take a couple questions from the group and then kind of finish up our time here. So let me see what we've got here. Give me one moment. I'm giving us a little something to kind of enjoy our finishing our time to. So I believe it's Andy. Is there a way to, is it Andy, right? I think so. Is there a way to view the code and check the security settings, like a filter? So I guess maybe he means like reviewing your code and ensuring it's secure to go up to Azure. Andy, can you just let us know if I get that right?
Yeah. I think the thing, and this is going to be like maybe this is the worst answer you've had today, but the simplest one you're going to have today is that like AppSec is AppSec, right? Mm-hmm. Most of the, actually the interesting fact is that OWASP do the OWASP top 10. All right. They then created the serverless top 10. Guess what? They're exactly the same 10, right? There's slightly different ways in which people attack them, but they're the same thing, right? So it's super important to just do AppSec, right? And a lot of that is done way before you get to functions, right? You should be deploying to production code through a DevOps pipeline. And as part of that, you should be writing your code to GitHub, a source repository, doing dependency checking, static code analysis, dynamic analysis. You should also be, as part of your build pipeline for your Azure resources, you should be scanning those for potential vulnerability, right? There's some tools like the Azure Secure DevOps Toolkit that you can use to run against your ARM templates that are about to be deployed and see if it's secure. There's a bunch of stuff that if you want to specifically do serverless security, there's a couple of companies out there. There was Protego Labs and then PureSec. And PureSec got bought by Palo Alto, if I got this right way around, and Protego got bought by Checkpoint. And the earlier is actually part of the Prisma cloud product that Palo Alto offer. Actually, as part of they offer like a serverless security scanning service. Aqua Security in the container space have a serverless offering as well for scanning, specifically for security workloads. If you're looking for that kind of baseline thing, Andy.
Great. Well, you know what? I think we got time just to kind of give people information. Dean, where do you think they can best find anything they may want as far as getting in touch with you? Maybe code projects you're working on right now, anything like that. Any way we can easily find you other than that little Twitter handle that you've got right there?
Yeah, it's there. Yeah. Oh, it's there. Hold on. I can't do that stuff. It's all backwards. It's like the so Twitter's probably the easiest place to get me. My DMs are open if people want to hit me up and follow up with questions and ask stuff. There's a lot of the stuff. You can also find me a lot of the content and projects that I'm working on. I run a meetup, Cloud Security London, www.cloudsecuritylondon.com. And at the minute, if you're not in London, like we're virtual, right? So it doesn't matter where you are in the world. And if I'm building cool stuff and serverless projects and tools, I'm most likely to demo them and present them there. Probably is the first place you'll see them. And then after that, they'll make their way onto publicly on GitHub or whatever after that. So yeah, Twitter's probably the best place if you've got specific questions, but I'm hanging out there too.
Awesome. Well, hey everybody, we got Dean again. We'll be back next week for the last one of the year. Dean, thank you so much for being part of this. I really appreciate you coming on here again. It's always been fun. Hey, Andy, thanks for coming along with us. I think we had a nice time. Everybody, have a great rest of your day. Enjoy your Friday. Have a great weekend. Dean, have a great evening with the family. Thanks again.
Cheers, Jay. Thanks all.